but I'll just go over it quickly. So your task was to decide if these following numbers were rational or irrational. Square root of 47. Let's go back to that. This is a square, right? And if you know the characteristics of a square, the sides measure, all the sides have the same length. Now, if I were to tell you that the area of the square was 47, could you find two of the exact same numbers that multiplied give you 47? For example, let's use this as an example. Right, if the area of this square was 25, and I asked you what are the sides length of this square, you would say that this is 5 and 5. 5 times 5 is 25. Now, it's 47, so 25 is called a perfect square for that reason. 36 is also a perfect square. If we were to find the side length here, you would tell me that's 6 and 6. But 47, unfortunately, is not a perfect square because there are no two numbers exact that multiply give you a square, what do you call 47. So if you were to take the square root of 47 in your calculator, and I'll do that here, you would get this answer right now. 6.855. Yep.
Are you working with Sarah?
No, she's gone.
She left for the day?
Yep. And you take that number and multiply it by itself, right? Let's see if you get 47. Now, 6.8556546 times 6.8555646, you get 46.9999. That's not, and etc., right? 104. ... Not 47. So because this ends up being, the square root of 47 ends up being a decimal that goes on forever and ever and does not repeat, we put it in the irrational side. 19 over 4, remember we define rational numbers as any number that can be expressed as a ratio of two integers. Can be written as a fraction? Yes. Rational. Fraction. Rational. Square root 84, not a perfect square. Irrational. 72, square root of 72 again, irrational. No two numbers, no two exact numbers multiplied will give you square root of 77. 8 over 9, rational. 7, we know it's a whole number, an integer, counting number, so that's on the rational side. Negative 4 is an integer, and therefore rational. Negative 11 is also rational. Square root of 59, again, it's not a perfect square, so that's going to be irrational. 11 over 9, rational. Square root of 96, irrational. Okay. 15 over 4, it's already a fraction, so that's rational. Negative 9, also rational. It's also a integer. 0 is a whole number, an integer, and rational. 3 is counting, a whole number, and an integer. Negative 7 is also rational. 5 is rational. Negative 14 is rational. And 9 is rational. Right, so remember counting numbers, 1, 2, 3, and so on and so on. Whole numbers is 0, 1, 2, 3, right? So it's the previous set plus 0. So integers is whatever was there before. So 0, 1, 2, 3, ... was there before. But now we have their opposites, negative 1, negative 2, negative 3, ... And rational numbers is everything that was there before, but now we have the fractional parts, right? Or the partials. 3.2, 7 over 9. What kind of decimals? Well, your regular decimals. They're terminating, the ones that end, and the ones that repeat. For example, this one or this one. Right? 0.333 forever and ever and ever. It repeats, so therefore it's rational. Irrational numbers. Square root of 2, and let me show you. Square root of 2 on the calculator would give you 1.41421356 and ... You can tell it's a decimal that never ends and goes on forever and doesn't repeat, so it's irrational. I can't change that. I can't write this as a fraction because I don't know what that last term is or that last number is, and if I don't know what that last number is, I don't know what place value to put. Okay, so this is irrational. So we did that in class. This one, Tell whether each expression is rational or irrational. So the first one, let me change that. Negative square root of 64 is, square root of 64 first of all is 8, and then put a negative sign, and then that becomes an integer, which is rational, put a little r. 1600, square root of 1600 is 40, right? And that's definitely rational. Plus or minus 160, well, first of all, square root of 160 is, let me write that, plus or minus 12.64911 ... So decimal that goes forever and ever, does not repeat, therefore irrational. Square root of 144 is just 12, so that makes it rational. Square root of 125, that goes on forever and ever. So let's see how I should find it out. It's 11.1803989 ... irrational. Square root of 340, again, not a perfect square. Right? No two numbers alike, no two exact numbers multiply, so negative 18.43908891 ... irrational. Square root of 1.96, well, that is 1.4. So if you take 1.4 times 1.4, you get 1.96. So that makes it rational. It's a terminating decimal. It ends right there. Square root of 0.09 is negative. Well, I mean, the negative is outside, so 0.3. So if you multiply, so if you take 0.3 and multiply by 0.3, guess what? You get 0.09. And 0.3 is a terminating decimal. It ends right there, which makes it rational. All right, so the next section, I think I can do it on the sheet itself. So, and again, we did these. So just going over. Here we go. Which set only includes rational numbers? So number one, that's irrational. Sorry, irrational numbers. That's irrational. That's okay. 3.76 with that little bar notation. Guess what? Makes it rational. Any decimal that repeats, right? It's rational. Square root of 36 is just 6, so that's also rational. So A is definitely out. B, negative 7.2322 goes on and forever and never repeats. That's irrational, so check. Square root of 15, that's irrational, right? It's not a perfect square. Square root of 15, square root of 15 is also irrational, check. 8.27451 goes on and forever, never ever repeats, irrational. So right off the bat, that's our answer. Let's do 5. Which one of these is an irrational number? So 4 over 3 is already a fraction, so it makes it irrational. Square root of 24, think about it. If that was a square and the area was 24, do you know two numbers that are exactly the same that multiply gives you 24? No. So you know that this is going to be an irrational number. Square root of 81 is 9. And if it's 9, that's irrational. And negative 4.07 is just rational. So which of the following is irrational? B. Which list contain only rational numbers? Well, negative 4 is rational, 0 is rational, 1 over 4 is rational. And if you actually take the time and put square root of 9 over 4, you're actually going to get 3 over 2, which is a fraction and also rational. So that is A is correct. Let me just do B. 0 is rational, half is rational, 1.5 is rational, but square root of 8 is not a perfect square, so you're not going to get a whole number or an integer. So therefore, this is irrational, but we want everything to be rational, so that wouldn't work. So the only one that works is A. Let me just lower the page. So again, I think we did these. We want a set that only has rational numbers. Irrational numbers. Negative 8 is rational, so right off the bat, 8 is out. B, negative square root of 64. Well, 64 is a perfect square, so this actually is the same thing as negative 8. And negative 8 is rational, so that's out, because I want just irrational. Square root of 26, that's irrational. Square root of 16, well, square root of 16 is 4, and with a negative, it becomes -4. That's rational. So C, I don't want. Well, square root of 50, not a perfect square, so that's irrational. Square root of 13, not a perfect square, irrational. Square root of 10, not a perfect square, so irrational. Square root of 54, not a perfect square, irrational. So final answer, D. What type of number is square root of 26? Well, put it in your calculator, iPad, computer, and you're going to get that it's 5.09901949514. So if you took that and multiplied it by the same exact number, would you get 26? Well, let's multiply this times itself and round it. Actually, the calculator here. You're going to get a number very close to 26, 25.999, etc. So square root of 26 is not a perfect square, so that makes it irrational. It's definitely not a whole number. It's definitely not an integer, right? Because it's a decimal that goes on forever, right? And then, sorry, it's not 25.99999. The end numbers will be whatever. So let me just see. Actually, it's just irrational. Let me 5.09901. Let me multiply that times 5.09901. Enter. So again, you would have 25.9999028. Okay, it's not 9999 forever and ever. The ending, depending on how many numbers you're multiplying, will always be something other than 9. So it's not a repeating decimal. Which number below is an element of set of irrational numbers? Well, square root of 4 is just 2, right? 3.45 is just an old-fashioned decimal, rational number, so this is rational. Negative 8.7, also a rational number. But square root of 2, right? So there's no two numbers, right? So if this was the area of a square, can you think of two numbers that multiply give you 2? Those two numbers being exactly the same? No. What does that tell you? It tells you that's irrational, because if you actually were to calculate that, you would get a decimal that goes on forever and ever and does not repeat. Which, I think we have to do 3. Which one only contains irrational number? Right off the bat, A is not it, because 2,300 is rational, so that's gone. 18 is rational, so that's gone. 3/8 is rational, so that's gone. I want everything to be irrational. Oh, sorry. I read the question correctly. Which of these groups have an irrational number in between? Well, this is rational, this is rational, this is rational. Rational, rational, rational. So now this is rational, but square root of 52 is irrational. So C would be my answer. Which of the following is an irrational number? Well, square root of 16, we know it's 4. Square root of 144 is 12, and 12 is just a nice whole natural integer, right? Square root of 4 is 2, so that's rational. But square root of 3 is a decimal that goes on forever and ever, right? It's 1.7320508088, so forth and so forth, which makes this guy irrational. Which set of numbers contain only rational numbers? Well, square root of 21 is just a fancy way of saying 11. Square root of 196 is just a fancy way of saying 14. So that's rational, that's rational. Square root of 24 is irrational. Okay, so that's not the one we want, so A is gone. We want only rational numbers. 144 is, square root of 144 is 12, that's rational. 13/2 is rational. 5/3 is rational. And square root of 3, not rational, it's irrational, so that's not what we want. We want everybody to be rational. Square root of 169 is 13, that's rational. 5/2 is rational. Square root of 21 is 11, so that's rational. And 14/4 is rational, so C looks like our answer. And D is not it, because this guy here, square root of 31, is irrational. Okay? Okay, so this side you can actually probably read it. So which number represents a rational number? Okay. Square root of 2, is there a square root of 2? Is it? No. It's not a perfect square, so this is irrational. Square root of 5, also irrational. Square root of 10, irrational. Square root of 25, it's easy. That's 5, because 5 times 5 is 25, right? So imagine that square. The area was 25. What could be these two sides? Well, this is 5 and this is 5. So square root of 25 is 5. So, and 5 is a rational number, so that's our answer. Square root of 50 is not, because it's irrational. Which number represents an integer? Remember what integers are, right? So negative 3, negative 2, negative 1, 0, 1, 2, 3 are all the whole numbers and their opposites, right? So square root of 2, definitely no. 10 over 21, definitely no. Square root of 21, definitely no. 10, is 10 in this set here? Yes, it is. 10 it is. Which number represents an irrational number? Well, 40 is just rational. 0 is rational, so we don't want that. We don't want this. And square root of 9 is 3, and we don't want that because that's rational. 9 is just rational because it's counting an integer and a whole number. But square root of 40 is a decimal that goes on forever and ever and does not repeat. So 6.324555532 ... A decimal that goes forever and ever and doesn't repeat. And if you were to multiply these two, you would get something like this: 39.9999 and then 8 something. Okay, close to 40, but not 40. Which number represents a rational number? Well, square root of 2, irrational. 2 over 3 is rational. Right? It's a fraction, right? So remember, if you can express a number, write a number as a ratio of two integers, then it's a rational number. And this it is. It's a ratio of two integers. We have a 2, which is an integer, and a 3, which is an integer. So writing as a fraction makes it rational. This, irrational. This is irrational. And this is irrational. So the only correct choice is that. Use the following list of numbers to answer each question below. Identify an integer from the list of numbers. Okay, so which one is an integer? Well, let me change. So 16, instead of 16, I'm going to think of it as 4. So here we go. 4 is the only integer. I can change square root of 16 to 4. Everything else I can't change. And I identify two rational numbers from the list of numbers. Okay, so two rational numbers. Well, 7 over 8 is a rational number. And then I can use the 4 again. That's the rational number. I can use this guy here. 3.692692 bar notation on this, which means this is actually this number. 692, 692, 692, 692, 692. Is it a repeating decimal? Yes. That goes on forever and ever? Yes. So that's also a rational number. Okay. Identify three irrational. Well, square root of 30. That's irrational. It's not a perfect square. Square root of 1/4. Actually, sorry, not that one. Square root negative 42. And then 4 pi. Square root of negative 20. And then square root of 1/4. If you put square root of 1/4 inside your calculator, you're going to get a half. So this guy can be also be written like that. And that I'm going to put over here because it's a rational number. Right, so think about a square, right? And I told you, hey, I multiply two numbers and I get 1/4. What were the two numbers? Well, one of them was a half and the other one was a half. What's a half times a half? 1/4. So square root of 1/4 is a half, and the half is written as a ratio of two integers, so makes it rational. So that's it. Cross out one number which does not belong in the sentence. Okay, so whole numbers. Well, whole numbers are 0, 1, 2, 3, ... So who doesn't belong here? Well, 0 is okay, 1's okay, 3 is okay, 7's okay. This guy, 8.5, doesn't belong there. Integers. Well, integers are the whole numbers and their opposites. -1, -2, -3, and so forth and so forth. So -8 is good, 0 is good, 5 is good, 3/4. No fractions in integer families. So this guy is out. Rational number. Anyone that I can write as a ratio of two integers. 14 is irrational. We knew that. 3 over 5 is irrational. Negative 2.4 is irrational. Square root of 81 is just 9, and 9 is irrational, so that's irrational. 0.333333 forever and ever. Is that a repeating decimal that goes on and on but repeats? Yes, so that's rational. 100 is rational, but square root of 40, it's not a perfect square, so think about the square and 40 here. Are there two to the same number that multiply give you 40? There isn't. You're going to get a decimal that goes on forever and ever, it does not repeat, so 40 is the one that doesn't give square root of 40. Irrational numbers. Square root of 3 is irrational, this is irrational. Square root of 49 is actually 7. And 7 is definitely not irrational, so this guy's gone. Everybody else is irrational. List 9 integers between negative 3.5, so look at the number line. This is negative 3.5 and this is 5.5. I want integers. Well, there's a negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. All these are integers and they're hanging between negative 3 and 5.5. List 6 whole numbers between negative 3.5 and 5. I get whole numbers. 0 is one of them. 1, 2, 3, 4, 5. Are those all whole numbers? Yes. And are they between 3.5 and 5.5? Yes. List 3 rational numbers. So here's the number line. Here's a 3, and here's 3.9. Can you give me rational numbers that exist between these two numbers? Well, here's one. 3.00000001. 3.2. 3 3/4. 3.77777785. Is that in there somewhere between 3 and 3.9? Yes, it is. So we have so many that you can create. It's unlimited. Five, use a calculator to write a decimal expansion. So what's 5 divided by 12? Let's change that to a decimal. And that's going to be, right, so if you notice your calculator, let me explain this one. The calculator says 0.416666, I don't know, a bunch of sixes, and the last one is 7. And the only reason that's giving you the 7 is because they are rounding, right? So the actual answer in the calculator, right, is this, and they rounded, they cut it here because there was no more room, and that 6 makes that one go one higher. So, and they rounded it up. But in reality, 5 over 12 is 0.41, and which is the number that repeats? 6 repeating. Okay. 7 divided by 11. Now this one repeats as well, so it's 0.63 and 63. And who's repeating? The 63. 3 over 8 becomes, that one is nice, it ends. 3.5. Square root of 12 is 3.464, and if it's irrational, which square root of 12 is irrational, round to nearest thousand, so they want us to go to third decimal place, right here. Done. Square root of 4 over 9 is just 2 over 3. Now think about this. If the area of the square was 4 over 9, what two fractions did I multiply? Well, one of them was 2 over 3, and the other one was 2 over 3. Remember, they have to be the same, right? Because it's a square. So 2/3 times 2/3, does that give you 4 over 9? Yes, it does. So the square root of 4 over 9 is 2/3. 11 over 20, 0.55. 1 over 3, if you divide that in your calculator, you're going to get 0.33333333, or better yet, like that. Square root of 78, that's going to give you 8.831760,866, but they're asking us if it's irrational, we round it to a thousandths place. So let me write this, 831760866, but it's asking us to round, so which to the thousand. So that means my decimal goes up to here. If I were to round that, I would write 8.83, and that 7 makes that one goes higher, so 2. 11 divided by 18 is 0.61111111111, or better yet, 0.6 bar notation. True or false? 40 has an infinite non-repeating decimal expression. Yes. Square root of 40. Let me put that in your calculator. You're going to get 6.32455532. And that goes on and on and on and on forever and ever. Right? Square root of 40. Again, think about this. The square. You put a 40 here. Do you know two numbers that are exactly alike that you multiply give you 40? No. Okay, so you get an approximation, very, very close to 40. But this is a decimal that goes on forever and ever. It never repeats. So this one is true. The number 0.56 is a rational number. Yes, because that actually means this. Is that a repeating decimal? Yes. Is it a decimal that goes on forever? Yes. And that's why we have this bar notation. So that is rational. Negative 200 and 500 are integers. Yes, remember what integers are. 0, 1, 2, 3, 4, etc., etc. On the other side, they're opposites. Negative 1, negative 2, negative 3. So those are our integers. No fractions, no decimals. So is 500 an integer? Yes. Is negative 200 an integer? Yes. That's also true. All numbers with infinite decimal expansions are irrational. So is every number that goes forever and ever and ever irrational? False. This number, for example, 4.1237849324510 goes on and on forever. That's irrational. It doesn't repeat. That type of number, yes. But what about this number? 1.3333333333. That's a repeating decimal, right? The 3 repeats forever and ever and ever. So, would that be irrational? No, this is rational. The statement is saying that as long as you go forever, you're irrational. That's not true. Here's an example of a decimal that goes forever, but it's rational. And lastly, negative 8, negative 3, 5, and 7 are all whole numbers. Obviously not. What are my whole numbers? 0, 1, 2, 3. No negatives. Only every number to the right of 0, that is a whole number. No decimal, no fraction parts, no partials, okay? 6, 7, dot, dot, dot. Okay, I think that's it.